1. What is a function? Do the following represent functions or not? Explain why or why not to receive full credit for each problem. Okay, the first one is a table, so what we're going to be looking at is the input and the output. I notice an input of 1 has an output of 7, an input of 2 has an output of 8, an input of 3 has an output of 9, and an input of 1 has an output of 10, and we're looking for every input having exactly one output, and I'm going to circle these 1s because notice that 1 has 2 outputs. This is going to be a no, and my explanation would be that 1 has 2 outputs. All right, for part B, we're given a graph, so I'm going to be using the vertical line test. So if I start drawing some vertical lines through this function, through this graph, this first one touches through the graph one time, one time, one time, one time. So since the lines only pass through the graph one time, then yes, it would be a function. So we're going to put yes, and we can put it passes the vertical line test. Right. C. A teacher makes a table that lists the name of the student X and their birthday Y. Use a table, graph, or equation to help explain your answer. So I'm going to do a table. So we've got an X and a Y. Okay, X is the student's name, so we could do Julie Jones, and her birthday is May, because it says Y is their birthday, May 25, and then let's say we have Justin Jack, and his birthday is April 9, and then I could list another person in the class. We could list Austin Apple, and let's say his birthday is January 1. What I'm going to be looking for is, let's say if I listed Julie again, I'm assuming we'd only have one Julie in the Julie Jones in the class. There's not going to be another one. And so if I listed Julie Jones again, she'd have the same birthday. So there would be no way on this one that I could list the student's name and for them to have a different birthday. That wouldn't make any sense. So this is going to be yes. And I'm just going to say each student has exactly one birthday. Right? We could say every input has exactly one output as well. Okay, number 2, functions. Complete the table and graph. So this is going to be just some function practice. We've got the function, the absolute value of 2x minus 3, and we've got x values. So if you recall, what we're going to do is plug in these into my x. So we're going to, on this one, do 2 times negative 1/2 minus 3. So we'll do 2 times negative 1/2, that's negative 1, minus 3 is negative 4, and then the absolute value of negative 4 is 4. And then if I plug in 0, 2 times 0 minus 3, 2 times 0 is 0, minus 3 is negative 3, and the absolute value of negative 3 is 3, because remember the absolute values turned it into positive. If I put in 1/2, 2 times 1/2 minus 3, and again, you could I'm doing this by hand, but you could let your calculator types figure it out for you. 2 times 1/2 is 1, minus 3 is negative 2, and then the absolute value of negative 2 is just 2. And if I plug in 1, 2 times 1 minus 3, 2 times 1 is 2, minus 3 is negative 1, and the absolute value of negative 1 is 1. And then 3 halves, plug in 3 halves, 2 times 3 halves minus 3, that will give me 3 minus 3, which is 0, and the absolute value of 0 is 0. And then I'll plug in 2, I'll get 2 times 2 minus 3, 2 times 2 is 4, minus 3 is 1, and the absolute value of 1 is still just 1, because remember, it just turns the problem positive if it wasn't already positive. And then the last time, 2 times 5 halves minus 3 would end up being 5 minus 3, which is going to be 2, and the absolute value of 2 is 2. All right, and then I completed the table. It does say to graph it now. So let me go ahead and draw a graph. So this one I'm going to go to the left 1/2 and up 4. The next one I'll stay put and go up 3. Next one I'll go to the right 1/2 and up 2. Next one I'll go to the right 1 and up 1. Next one, I'll go to the right 3/2, which would be 1.5, and I'll stay put. Ooh. And then the next one, 2, I'll go to the right 2 and up 1. And then my last one, I'll go to the right 5/2 would be 2.5, and I'll go up 2. It looks like I lost my point there. And then I could go ahead and connect them because it looks like it's making a nice little pattern here. So there we go, we graphed it. And then it says to use your table and graph to explain why the equation above is a function. Well, first of all, for my table, I could say that every input has exactly one output. And then for my graph, if I drew vertical lines, notice it passes a vertical line test. So I could now on this one say it passes the vertical line test. All right, problem 3, let f of x equal x squared minus 4. Evaluate f of 5. Remember what we're going to do, wherever we see the x, we're going to put a 5. So we're going to have f of 5 equals 5 squared minus 4. And so we're going to have f of 5 equals, 5 squared means 5 times 5, which is 25, minus 4 is 21. So f of 5 equals 21. Right, number 4, in the following graphs, identify the domain and the range. All right, if you recall, the domain is a list of the x values, and the range has to do with the y values. So this first one, we are given 4 dots, so we actually are going to make a table of those 4 dots. Okay, this first one right here that I'm circling, I'd have to go to the left 1 and up 3, so it's going to be negative 1, 3. This next one is to the right 1 and up 3, so I'll put 1, 3. And then the next one is going to be to the right 3 and up 3, so I'll put 3, 3. And then the last one, you'd go to the right 5 and up 3, so it'll be 5, 3. And so for this one, the domain is just a list of all the x values. So it's going to be negative 1, 1, 3, and 5. And the range is a list of all the y values, and all the y values are just 3, and we do not duplicate numbers, so that would be it. Okay, for B, this is going to be a little bit different. This one, I'm just going to go ahead and write domain and range. And if you have your hands, hopefully you're using your hands. Remember, domain is going in my x direction, so I'm going to, if I would be spreading my hands out from where on the left to where on the right, so the way over to the left, it goes over, it looks like negative 5 to the left. And then I'm going to put a dash because it goes through. Going to the right, how far does it go to the right? It looks like it goes 6 to the right, so that would be my domain. All right, my range, I want to see how high up and how far down does it go. So I'm going to be putting, if I had my hands out, I'd go this way instead. Okay, so I'm going to look at how low does it go. The lowest that it goes is down to negative 1, 2, 3. So negative 3, 2. And then if I want to look how high up does it go, it goes up to positive 4 about. So that would be my range.